Good afternoon. The title of my reflection video is the Digital Mouth and Ears, an academic exploration of speech to text and text to speech technologies. Now, let me start. In the contemporary digital landscape, how individuals interact with technology is undergoing rapid transformation. Central to this evolution are speech to text, also known as STT, and text to speech, also known as TTS, technologies. ST STT facilitates the conversation of spoken language into written text, whereas TTS performs the reverse function by converting written text to audible speech. These technologies are significantly reshaping the paradigms of communication, learning, and professional interaction, offering considerable advantages to both individuals and organizations. Now, a historical overview in which the development of STT and TTS technologies. The underlying principles of STT and TTS can be traced back further than commonly presumed, in which the trajectory from primitive conceptualizations to the advanced systems prevalent today exemplifies decades of innovation within the realms of computer science, linguistics, and artificial intelligence. The immersion of voice recognition, also known as STT, in which the inception of STT technology traces back to the 1950s, character- characterized by initial experiments in recognizing spoken digits. A pivotal milestone occurred in 1952 with the introduction of Bell Labs' Audrey system, which is notable for its ability to identify a single voice uttering numbers. The progression continued into the 1960s, marked by IBM's Shoebox, which could comprehend 16 English words. Then the 1970s heralded the development of hidden Markov models, also known as HMMS. While in the 1980s ushered in a transformative shift towards statistical modeling techniques, recent advancements in the machine learning and deep neural networks have propelled STT systems to unprecedented accuracy levels, embedding these capabilities into the fabric of daily life. Now, for the mechanisms and operation of technology underpinning STT and TTS. The operational frameworks of STT and TTS are intricate, relying on sophisticated algorithms and models to facilitate the translation between human linguistic expressions and digital information. STT at its core is a system that captures auditory signals and encodes them into digital format. This digital representation is subsequently decomposed into smaller, recognizable units also known as phonemes. The system employs an acoustic model to analyze these phonemes in conjunction with a language model that predicts probable word sequences based on contextual language patterns. It process generally entails several steps, which is first is the analog to digital conversion, which is a microphone that captures the sound waves associated with speech, transforming them into digital signal. Step two is acoustic modeling, in which analyzes the digital signal to identify distinct phonemes. Step three is the language modeling. It's in which the software compares the identified phenome sequence against extensive database of words, excuse me, and phrases to ascertain the most accurate textual representation. And the last step is text generation, in which the system ultimately produces the written output of the recorded words. Now for the TTS, it ingests written text as input and generates an audio waveform reflective of the text spoken form. This process encompasses the two primary stages. Stage one is text normalization and linguistic analysis, in which the system first processes the input text, expanding abbreviations, recognizing numeric values, and determining correct pronunciations based on the conceptual usage. Additionally, it examines sentence structure to ascertain appropriate intonation and rhythm. And stage two is waveform generation. It's the process linguistic data is employed to generate sound waves, which modern neural network-based systems can produce speech that can closely mimics emotional tones. Now, for its applications in the workforce and educational context. The practical application of STT and DTS are expansive, which yields significant impact within professional and academic environments. Now, for the workplace, some of these examples are meeting transcriptions, which can facilitate automatic transcription of meetings, interviews, and conference calls, generating searchable records that enhance operational efficiency. Another example is dictation and documentation, which across various sectors, including healthcare and law, leverage STT for dictating notes, reports, and electronic correspondence. Another example is voice command control and voice control. Integration of TTS and STT fuels voice activated efficiency. Lastly is accessibility, which is fundamentally both technologies serve to foster inclusively in workplace settings. In summary, STT and TTS technologies represent pivotal advancements that continue to redefine human interaction with technology, promoting enhanced communication with accessibility in operational diverse domains. That would be all. Thank you.